Hi, everyone. Thank you for taking the time with me today to listen in for this talk. So my goal is to give you some useful information about the Amazon EC2 instances where we feature AMD CPUs. A little bit about myself. My name is JD Koos, and I've been building and working with servers, storage, and networking systems for about 13 years, doing that at Hewlett-Packard for some time, then doing that at Cisco, the last few years at Broadcom, and then just joined AWS in this year in 2020. I have a really strong passion towards building infrastructure that's more efficient and really trying to help customers to take advantage of that infrastructure. And in the role that I'm currently in, I am the product marketing lead for EC2 instances, specifically where we feature AMD CPUs. We're a pretty small team, just a few of us, and we are focused on the core of EC2 for product marketing. So let's go ahead and get started. So this is an interesting picture I like to spend just a minute on to kind of set the stage. So Gartner's actually very particular when it comes to the methodology that they use for the axes that really come about on this quadrant. And they take a very close look at the offerings that are available across the industry. This particular quadrant is focused on cloud infrastructure as a service, where AWS has been able to lead for a number of years with EC2. And kind of from my perspective on this quadrant is that I believe when innovation and execution are able to go hand in hand for a sustained period of time, that's what kind of allows the organization to finally do well in a Gartner Magic Quadrant. And in the case of EC2, I think it's really the breadth and depth of the offerings, the speed of the delivery of the innovation, the size of the community that is really helping us improve the product and has been doing that for a number of years, and then the maturity of the platform having been delivering infrastructure as a service for over 13 years are really what allow EC2 to kind of have this leadership position. So in the discussion today, I hope to get you excited about some new innovations that have just recently come in EC2, what we call the Elastic Compute Cloud. So what does Amazon EC2 look like today? Well, really for all sorts of different workloads, ranging from just like a single server test environment where a developer just wants to see how code runs, all the way to really scaled up or scaled out infrastructure that's powering mission critical applications such as like self-driving cars or bank transactions. We offer different capabilities really to match customer needs. So all of these options that you see here, really from all the way from a GPU dense system where you're going to be able to potentially leverage all the way up to 8 GPUs in a single system, to a system that would include FPGAs, to ARM-powered instances, or to a single instance where you can actually support up to 24 terabytes of memory. Network speeds from 1 gig to 100 gig, and what we consider unlimited storage capacity at very high levels of performance with block level access. So you can run literally any file system or any storage stack that you want. It creates what we think of as the power of choice for our customers so that you can choose EC2 instances really that match your business and your application needs. So as we go forward in the presentation today, we're going to talk about a subset of the over 300 today. In fact, it's just pushed over, I believe, 350 EC2 instances that are available today where we feature AMD processors. So if we think about the categories for EC2, some of the most popular are going to be the compute optimized category, general purpose, and the memory optimized categories. And these instances are really built to give customers the ability to have a broad set of options. Yet when you drill down into each category, you'll find that you have many choices of instance sizes within each of these at what we consider pretty granular level. So customers also in the last few years have been asking to give us more options really across the board. And specifically, there's a lot of interest today in leveraging the AMD EPYC line of server CPUs. So if you look at these three categories of instances, you'll see that the AMD EPYC, we kind of have that mapped there, really are going to be available across a broad range across the compute optimized general purpose and the memory optimized instances. So as we go forward, we're going to kind of dive deep into some of these categories and specifically give details on what these look like and how you can leverage them. So if we look at the EC2 instances where we include AMD processors, there are really a couple things that stand out. First, when we're able to find a way to have a high quality product and then reduce the price, our goal is always to pass those savings along to customers. So you'll find that the EC2 instances that feature AMD are going to have actually a reduced price when we compare them to other previous generation comparable instances. And another benefit that AWS offers is really the ability to let customers define their workloads based on the processor that really fits the needs, because there really is a large set of potential applications for different processors. And in this case, with EC2, you have the ability to run AMD EPYC, Intel Xeon, as well as AWS Graviton 2 processors. And there's one more feature that I think is noteworthy, and that's that we have this strong focus on making the experience be very simple for customers, not just to deploy, but to manage and to migrate to newer instances. So towards that goal, what you'll find is that if you're using, for example, an EC2 C5 instance, it's very easy to migrate to a C5A. And the same would go for an M5, an R5, and a T3 instance. If you were running those instances today, it'd be very simple to move to one of those other instances. And this is an area where we've gotten customer feedback, and we will actually talk about that a little bit later, some customer stories about making those migrations. So a really good place to start as we dig in here and start to look at specifically how we can leverage AMD processors in EC2 is to start with the general purpose instances. So let's go ahead and do that. So within the general purpose compute category, we call the EC2 instances where we have AMD processors the M5A. And the general purpose, these general purpose instances really are built to have a balanced ratio of memory in gigabytes to compute in what we call vCPUs at a ratio of 4:1. You'll see this kind of come up as we go through each of these, at that ratio of gigabytes of memory to vCPU. So all of these instances, there are many different sizes, but they will all have that same ratio of 4:1 memory to CPU. So the EC2 M5A instances actually utilize AMD's first generation EPYC 7000 series CPU, also known as Naples in the industry. Now these instances, they feature high network bandwidth as well as high throughput to the Amazon Elastic Block Store, or EBS. And this is Amazon EBS is block level storage that's really designed for use with EC2 at what we call any scale. So the M5A instances, they're available actually in 8 sizes without local NVMe storage and 8 sizes with local NVMe storage, for actually a total of 16 different options that you have once you drill in and really try to right size for an application or a workload. So although the general purposes are actually very nice because they have a broad application, there are some times when instance utilization is really not going to be very predictable. And I think we've all looked at CPU utilization charts over time and seen stuff, seen things like this. And it's kind of in this situation where some workloads, we do know when there's seasonality, if we're running a batch at the end of the month for some sort of processing, if we know that certain times of day are going to be spiky. But imagine if this was a 6-month time frame, and if you kind of look and you see the average, if you really were to take the average of this time frame for CPU utilization, is very low. Yet you have these very large, very significant deviations in very even short-term spikes. So how do you build for a system like this? If you were to say spec a system that solved for the highest common denominator. Imagine really speccing a system for the highest level of CPU utilization, or maybe taking an average of the top few spikes here. You would still have a system that on average was very overspecced and very underutilized. So what do we do to kind of solve for this kind of a workload? So in order to address this, what we've built within EC2 is the T3, what we call the burstable instances. T3A is the name, where we feature AMD processors. And the T3A instances, we call them a low-cost general purpose instance that really gives a baseline CPU amount and then the ability to burst potentially very high above that baseline. So the T3 instances, they're really the lowest cost EC2 instance. And we consider them to be some of the ideal use cases are web servers, developer environments, small databases. There's a very large set of actual potential applications where you really don't know what the spikes are going to look like, and you really don't know how often they're going to come, but you do know that they don't come all the time, and you do know that they're unpredictable. So these instances are available at a very low cost and include the AMD first generation Naples processors, the 7000 series that we mentioned on the M5 general purpose before. So now another thing we've heard and kind of built into EC2 over time is that customers have asked us for more memory optimized and more memory dense systems. So what we've created a whole family or a whole category of instances featuring AMD processors that are called the R5 instances. So let's take a deeper look at the R5 instances. They have an 8-to-1 ratio of memory in gigabytes to vCPU. So of course, that's twice as dense in memory compared to the general purpose instances we just talked about. So this would be, of course, for applications that really can benefit from having that additional memory footprint. So the R5A instances, just like the T3A and the M5A, they feature AMD's first generation 7000 series Naples processor running up to 2.5 gigahertz. Just like the M5A, these are available actually in a total of 16 sizes. That's 8 sizes without local NVMe attached and 8 sizes with local NVMe attached. And in all cases, all 16, just like with M5A, all have access to remote block level storage EBS that's high performance as well. So some of the more ideal use cases that we see, or most common use cases that we see in kind of painting broad strokes, would be for enterprise applications that require a lot of DRAM, like SAP, Oracle, SQL Server, various high performance databases, and then even in-memory databases can be a very strong set of use cases that would match well for R5A. So kind of on the flip side to the memory dense system, we have many workloads that require less memory and actually then an increased ratio of compute. So enter the C5A instances. As this family are considered to be the compute optimized family, and they are then at a 2-to-1 ratio of gigabytes of memory to vCPU. So now twice as dense in CPU as our general purpose, and 4 times more dense than the memory optimized. So these instances they actually feature the second generation AMD processors of the called the Rome generation, running up to 3.3 gigahertz. And they're also available in a total of 16 sizes. That would be 8 without local NVMe and 8 with local NVMe attached. These instances we see being used quite a bit for applications like gaming, both single and multiplayer, things like log analysis, various batch processing workloads, some web applications, and even things like distributed analytics. So the C5A instance offer this price performance benefit compared to comparable instances, and they actually represent the lowest cost per x86 vCPU in the entire family of EC2 instances. So to kind of sum up how we want to think about these different instances where we can take advantage of AMD CPUs, how do we want to really think about these together? So I think it's worth mentioning that we always have the ability to use a local solution architect or local sales representative to help assist in right sizing. Additionally, the AWS website has a number of tools that will help us right size either based on application, whether we've got data looking at kind of what utilization has been like in the past, whether it's storage, memory, CPU bound kind of applications or network bound. And there are a lot of ways to help you right size before deploying. And then when it comes to tools that are on the website, and I think it's worth mentioning that once you do deploy, one of the strong features of EC2 is the ability to say, okay, now I've deployed at this level or for this particular size instance, but I need to adjust that. So we definitely offer what we call auto scaling to be able to make those reactionary changes automatically. And then to make proactive changes is also a relatively straightforward action. So once you do get in, you can definitely change that even when you're in production. So to kind of recap as a summary of the instances where you can leverage AMD processors, so you have the M5A instances that we consider general purpose, the most balanced compute, memory, and network resources for the broadest set of use cases. Then the T3A, or the burstable instances, they're a great fit for when you really don't know when you're going to have potentially very large spikes in CPUs and you don't know when they're going to happen and you also don't know how high they're going to be. Then the R5A instances, they're designed with the highest ratio really of memory to CPU. And the C5A are optimized for compute-heavy workloads with a very high ratio of compute to memory, as we've just talked about. So all these instant types are available. Once you click in and you start to see, you've got a number of different options within, all the way up to 16 on all of them, except for the T3A, which has 7. And that way you can really run your application with the right level of compute in the most efficient way. So let's take a look, I think transitioning, take a look at where we can actually use AMD-based EC2 instances across the AWS global footprint. So EC2 overall today is available in 24 regions, 77 availability zones, and then 216 POPs, some people call them, but we kind of think of them as edge locations where they're really built for extreme low latency. So this global footprint for EC2 is one of the reasons I think that EC2 was able to see in a recent non-commissioned study 1/7 the amount of downtime as the most closest competitor when it comes to infrastructure as a service. So AMD is kind of today ever expanding in terms of its availability across this global infrastructure, AMD-based instances. And just in this last August, we rolled out availability for 7 additional availability zones, or 7 additional regions. Within those regions, many availability zones. So that one thing we should expect is for this slide, definitely expect even within the next months here, this slide should go outdated pretty quickly because we're constantly adding new regions where you can take advantage of AMD processors. And this information is kept up to date on the AWS websites. So one of my favorite things to do is to think about what customers are actually able to do. What were the practical abilities and the practical things that customers are able to do? That game company, they're known for making really visually stunning video games, and they have workloads that are very compute intense to create these video games. They just recently went from a transition from the C5 instances on EC2 to C5A, where AMD processors are used in the 2nd generation. And they experienced what we've hoped for, kind of in building this solution, is they experienced what they actually said in their words as having performance advantages and saving costs. And I really have to kind of double click on that for a second. The fact that they were able to save costs and see performance benefits, nothing puts more of a smile on my face than from a customer to be able to have both those things in one transition. So Wego, another customer, they're the leading destination for travel commerce online in Singapore. They just made a similar transition from the C5 instances to the C5A. They told us 0 code changes, minimal lift, and they said that the transition was completed in just a couple of days. And this was actually for their highest scale application, which today does have a very large footprint. They did put a metric behind the amount of performance, or I should say, in this case, cost savings, because they had such significant performance gains. They were able to really reduce the number of instances that they needed to use. So they're kind of a large set of examples like this that fortunately I get to see some of these case studies come in and get to work with some of these customers as they make these transitions. But these are just a couple of examples of, I think, very recent ones that give an example for how customers are really able to take advantage of the AMD instances and do things like save costs or get better performance, and in some cases do both. So let's summarize what we've really covered today. The C5A, the M5A, the R5A, and the T3A EC2 instances where we feature AMD CPUs, they offer 10% lower costs than comparable instances, which is with our goal of helping customers optimize budget spends on infrastructure. And another, as we've kind of talked through, another tenet of AWS is customer choice. And so with the addition of AMD, you have 3 choices for instance CPUs in EC2. That's AMD, Intel, and Graviton 2 based processors. And the C5A, the R5, M5, and T3A instances, they offer actually very similar virtualized sizes in terms of vCPU and memory compared to the C5, M5, R5, and T3 previous generation instances, in order to be able to make it a seamless experience when it comes to application compatibility as well as just workload fitment. So we've definitely had feedback come from customers that the migration to these new instances is actually very straightforward. And I think the last point really to make is, in some cases that you're going to find with the AMD-based instances, you'll have comparable performance to other systems, and there will be a 10% cost savings. And then in other cases, there's actually going to be a higher performance capability depending on the application, and then actually also a reduced cost that goes along with that. So the goal is to not just bring lower costs, but also to bring higher performance that would go along with that. So I want to thank you for taking the time to listen in today. I hope I helped you learn about how you can leverage the EC2 instances where we feature AMD processors. Thank you.